Hello, this is Ms. DB. In this video we are going to use rational exponents and nth roots. So the first part of this worksheet you're going to find real roots, and real numbers, remember you cannot have the square root of a negative number or any even root of a negative number, so we'll look at those. Fourth root of 81, let's look at this example. So when I talk about the fourth root, we know that the square root of 81 is 9. The fourth root will have a little 4 right here. And what it means, the square root of 81 means what number squared equals 81, right? That's what it means. And the answer is 9 because 9 squared equals 81. The fourth root means what number to the fourth power equals 81. So it's not 9 because 9 to the fourth is a much bigger number than 81. So you can do these different ways. You might have a calculator that will find different roots, but these really are all going to be easier probably to find just by thinking about it and then maybe doing some guess and check on your calculator. So to find the fourth root of 81, maybe I'll do 2 to the fourth power on my calculator, and I'll see that that is not 81. That doesn't work. How about 3 to the fourth power? So get your calculator. This is the calculator that is just on my computer, which works good enough for this. 2 to the fourth power, I'll do that one first. Here's where the powers are, and it's x to the y. You get to pick anything you want. So 2 to the fourth power, I would do 2 and then the x to the y button, and see there's that little up arrow like we use on our keyboard. To the fourth is equal to 16, too small. So I'm going to try 3 to the fourth power. That is 81. So now I know that 81 has a fourth root of 3. However, because it's an even number root, it would also be true that negative 3 in parentheses to the fourth root is also equal to a positive 81. So there's 2 answers for even numbered roots. Second root, which is a square root, fourth root, sixth root, and so on, if you're taking it of an even number. The cubed root of 125, negative 125, there's only one root for that, and it's negative 5, because negative 5 to the third power is equal to negative 125. And 5 to the third power would be a positive 125, so there's not 2 roots for an even one. And the sixth root of a negative number is not possible, because if you have, remember, the square root of a negative number is an imaginary number, a complex number. It's not real. It would be 9i if you want to go back to when we worked with imaginary numbers. But this asks for the real roots, and the real roots are not possible to have a fourth root or a sixth root or an eighth root or a square root of a negative number. Would be not possible. So when you're doing these problems, some of them will have one answer and some of them will have 2. Let's do and one of them will have no answer at all. Let's do the cubed root of 27. You can write it as a cubed root if you want, or you can just think about what that means. It means what number to the third power is equal to 27. So again, you can just try some numbers on your calculator. You can say, well, 2 to the third power, there's actually a third power on this version of the calculator. 2 to the third power, whoa, I got something going on here. 2 to the third power is 8. 3, I can use this again, to the third power is 27. Oh, so I found my answer. It's 3. Should it also be negative 3? No, because negative 3 times negative 3 times negative 3 would be a negative 27, which is not what I'm looking for. I was looking for the cubed root of a positive 27. All right, next section on your worksheet, you are going to be working with rational exponents and nth roots. So rational exponents is when you have an exponent that's a fraction. A fractional exponent could be written as a root because it means 16 to the 1/4 power is the same as the fourth root of 16. So it's up to you to decide how it's easier for you to think about that as far as simplifying it. It's easy enough to write this, but it might be a little bit harder to think about how to simplify it. If I had the fourth root of 16, I would know that means I have some number to the fourth power that's equal to 16. And then I could get my calculator out and I could say what number to the fourth power is equal to 16. And I could try some numbers, and really quickly I find, oh, it's 2. 2 to the fourth power is equal to 16, which means that the fourth root of 16 is equal to 2. So in general, in algebra, this is true. If you have a fractional exponent, 1 over n, that's the index of your root. And you can also have a fractional exponent where 1 is not the numerator, and that means that you have something that's being squared as well. So this problem, 8 to the 2/3, could be written two ways. We could write that as the cubed root of 8 squared, or we could write it like they did as the cubed root of 8 and then the whole thing squared. It actually turns out to be the same either way. For simplifying this, you could find two ways. You could say, what is the cubed root of 8? Which means what number to the, I know what the answer is, what number to the third power is equal to 8? And you'd say, oh, that's 2. So that means that the cubed root of 8 is 2, and then 2 squared is 4. You could also do this. You could say, okay, 8 squared is 64, and I want to know what number to the third power is equal to 64, which maybe that's a little harder to know, but I know it's not 2, so I'll try 3 to the third power. I already know that's 27. That's not right. How about 4 to the third power? Yes. So that means that the cubed root of 64 is 4. So I could get that two different ways. And in general, this is how you would write either one of these ways is how you would write a rational exponent where it's not 1 in the numerator. And then there's some properties of nth roots. These are the same as the properties of square roots. If you have a root of a number, you can break it into a root of each factor of that number, because that might help you simplify it. And because, like in this case, the cubed root of 8 we know is 2. We just did that one. So we could write this part as 2, and then it would be 2 times the cubed root of 2. And you can also break quotients up into two separate parts and then simplify each part, which, like in this example, simplified it a lot. This is kind of a summary of what we looked at, and you can use that as you look back at the problems. In this example, example 2a, example 2b is a little bit more complex. I'm not going to look at that one. But if you want to look at how to rationalize the denominator of a non-square root, that's an example of that. But in 2a, this is similar to the problems you're going to be doing on this worksheet. So what they did first is they rewrote these in pieces. So they wrote 27 is 3 cubed, and they wrote x to the 6th as x to the 3rd times x to the 3rd. Now they did this because they're taking the cubed root of all of it, so they knew that that would help them simplify. Again, this is not the only way to simplify it, but this is one way that you could work on simplifying it. Another way of simplifying a would be taking 27 to the 1/3 power and x to the 6th to the 1/3 power. So writing it, instead of a radical, writing it as a rational exponent. And then figuring out what this is, well, that might make more sense to think, what is the cubed root of 27? But this is easier to simplify with exponents, because now we can raise a power to a power. 6 times 1/3, or a third of 6, is equal to 2, because it would be 6 over 3. So we will have x squared for that part, and then the cubed root of 27 is 3, so we'll get 3x squared. So again, there's more than one way to solve many math problems, and these especially are kind of like puzzles that you have to just try to keep working at until you get them as simple as you can, simplified as you can. So let's look at number 7. So in number 7, we have the cubed root of x to the 8th times the cubed root of x to the 4th. So again, there's more than one way to simplify this. Let me erase what I got going on here. One thing that you could do is, since they're both cubed roots, you could multiply the numbers inside of there and have x to the 8th times x to the 4th if you want to, if you think that will help. Or you could simplify each one separately and then multiply your results. Let's do the first thing that I said, and let's try that and see if it helps. So I'm going to multiply x to the 8th times x to the 4th, and that would give me the cubed root, so put a little 3 there, of x to the 8th times x to the 4th. But x to the 8th times x to the 4th, when you multiply the same bases, you add their exponents. So that's the same as the cubed root of x to the 12th. And now I'm going to write it with exponents, as rational exponents. So that's x to the 12th to the 1/3 power. And when you raise a power to a power, you multiply, and 12 times 1/3, that's the same as 12 over 3, and 12 divided by 3 is 4. So this all simplified fairly quickly to x to the 4th, which would be my final answer then. But again, that's not the only way you could do it. You could work with each part separately and then simplify what you have at the end. Let's also look at number 10. This one has a denominator. So I'm going to rewrite this as the 5th root of 64 over the 5th root of 2x to the 10th. And now I'm going to write these with rational exponents instead. Actually, for the 5th root of 64, I'm going to think about what that means. That means some number to the 5th power is equal to 64. Let's see if we can figure out what to the 5th power is equal to 64, if there is one. 3 to the 5th power is too big. 4 to the 5th power, whoops, not to the 55th power, is too big. 3 to the 5th power, oh, I started out with 3, didn't I? I went the wrong way. 2 to the 5th power is 32. So there is no number that the 5th root of it is exactly that. So I was hoping it would simplify a little bit easier, but it's not. So let's rewrite 64 as 32 times 2. Because did you notice that when I was doing that on the calculator, 2 to the 5th power was 32. So that means, this is just the numerator part I'm simplifying right now, that means that I could rewrite this as the 5th root of 32, which I know is 2, times the 5th root of 2. Let's look at the denominator now before we go any farther. The denominator I could rewrite as the 5th root of 2 times the 5th root of x to the 10th. Okay, so we have the 5th root of 2 on the bottom and the 5th root of 2 on the top. And then I'm just flipping the order of these using the commutative property. The 5th root of x to the 10th is the same as x to the 10th to the 1/5 power. So now we're making some progress here because I can cancel the 5th root of 2 over the 5th root of 2. They're the exact same thing, the same value, so they will cancel each other out. On the top, I know that the 5th root of 2, or the 5th root of 32 is 2. Now on the bottom, I have x to the 10th to the 1/5 power. When you raise a power to a power, you can multiply. What is 10 to the 1/5? Or 10 times 1/5? That's the same as 10 divided by 5. We know that that's 2. So this all simplifies to 2 over x squared. That's number 10. So again, these are kind of like little puzzles, and the first attempt you might make at simplifying might not work. Like I was unable to find the 5th root of 64, but then I realized that I could rewrite 64 as 32 times 2, and then I made some progress after that. So work with these like little puzzles, and you'll be able to simplify them as far as they can go. Now on this one, they're already written as rational exponents. So you might want to do, as they suggest in 13, rewrite it as a root, an nth root, and then simplify. But sometimes it's just as easy to work with them as rational exponents. So in number 13, the cubed root of 27 is 3, and you can find 3 to the 4th power using your calculator, and you'll find out what that is equal to. In 14, we have 49 to the 3/2 power. So that means you have the square root of 49, and for the square root, you don't have to put a 2 here. You can if you want. And then you could either cube that, or you can take the square root of 49 and then take that to the 3rd power. You could also write this as 49 to the 1/2 times 49 to the 3, because 1/2 times 3, when you multiply, wait, I did that wrong, 49 to the 1/2 to the 3rd power. And then you could say, well, what is 49 to the 1/2 power? that's the same as the square root of 49, which is 7, and then you'll have 7 to the third power. So in any case, you're going to get 7 to the third power, whether you do it here, or whether you take the square root of 49 here, and then raise that to the third power. And then you're actually supposed to write them in simplest radical form, and simplify, or write in simplest radical form. So not every one of these will be able to be written as a number. So 7/3 is 343. So for this one, we're able to get a number for an answer, but some of them you might still have a radical in your answer. Like 16. 16, that's the same as the square root of 6. The square root of 6 cannot be simplified. Don't take your calculator and say, what is the square root of 6? It's 2.49449. Don't do that. Just leave this as the square root of 6. If it can't be simplified, don't write it as a decimal. Just leave it as its radical form. All right, and then on this last section, this is the last section. It's more simplifying, and this time you're going to have it as a root, and you're going to write it as a rational exponent and simplify if possible. So like in number 20, you can write this as a rational exponent. That would be 19 to the 1/2 power. That can't be simplified anymore after that. The square root of 19 it does not have a perfect square, so we'll just leave it as 19 to the 1/2 power. But you can write it as a rational exponent. Similar, in number 21, this would be written as 6 to the 5th to the 1/4 power, which we can simplify by multiplying the exponents together and get that as 6 to the 5/4. This is not simplifiable. Some of them that are, but this one is not. So simplify these as much as you can, and it's okay to write them with a rational exponent. If you're typing, this worksheet is hard to do because you'll have to use the formatting that is available in Word to write these exponents and roots. So in 21, I can write that as 6 to the power of, and I can use the x squared button in my formatting tools. I'll show you that. I can use this, and I can write 5/4 as an exponent. Oops, 5/4 like that. I could do that, or you could write, still in exponent mode here, I could write 6 to the, and then I should really use parentheses to show that everything that follows is part of the exponent. I could do that. To write a root, though, is a little bit tricky for number, like if I wanted to write this as the square root of 6. So I can go to Insert, and I can use under symbol, you might be able to find the square root, or you can insert an equation, and one of the options in equations is this radical. And this radical, you can either do a square root, like if I know I just want the square root of 6, but if you need a cubed root or a fourth root, you can use this. So it looks like this once I insert that, and then this is where you would put your index, like this one is the square root. So I could have just wrote the square root of 6 for this one, but it's not wrong to put the 2 there. We just don't have to do it. Otherwise, it's pretty tricky to use roots that are not square roots, and you would have to like type it all out in words. So you may find it easier to use a piece of paper and take a picture of your work when you're done for this assignment. All right, thanks a lot. Have a wonderful day.